Coming on to the next second classification is on the basis of intermolecular force of attraction. The basis of intermolecular forces of attraction. First, they are classified into 4 types, and in 4 types, in the first one we are going to discuss is ionic solids. On the basis of intermolecular force of attraction, they are classified into 4 types. The first one we are going to discuss about is ionic solids. Just example of an ionic solid, if you take out NaCl, it gives ions which are nothing but Na plus and Cl minus ions. In the constituent particles, if you observe, constituent particles are ions. Example of ionic solid is NaCl, and NaCl has been break down into two ions. One is anion, another one is cation, and the constituent particles are ions. The force of attraction between cation as well as an anion is electrostatic force of attraction. Electrostatic force of attraction is observed or seen between a cation and anion. And in ionic solids, they have high melting and boiling point. Melting and boiling points are very high. Let us see once again what are ionic solids. On the basis of the intermolecular force of attractions, solids are classified into 4 types. First of all is ionic solids. In ionic solids, if we take out an example of NaCl, NaCl can be break down into 2 ions. One is a cation, another one is an anion, Na plus and Cl minus, and the constituent particles are in nature of ions. Whereas the force of attraction between both the ions is electrostatic force of attraction. And they have a strong melting and boiling point. Coming to the second type of solid is covalent solids. Covalent solids are also called as network solids. Covalent solids are also called as network solids. The type of force of attraction present in covalent solids are nothing but a covalent bond. Best example for the covalent bond we can observe is in the diamond or graphite, where in diamond we can observe 3-dimensional covalent network. This is due to the 3-dimensional covalent network. They show very high melting and boiling point. Whereas if you observe in diamond has an structure. They have a structure like this. Covalent network type of solid, and this is due to 3-dimensional covalent network. Covalent network, they show high melting point and boiling point. Just have taken small screenshot of it. Take a screenshot of it, and we'll see the other two which are left out. Just take a screenshot. Coming to the third one is molecular solids. Molecular solids are further classified into three types. They are classified into three types. One is non-polar molecular solids, polar molecular solids, and the another one is hydrogen bonded molecular solids. The best example for the non-polar molecular solids is, example for this is, let us take I2, iodine, where in iodine the type of force of attraction is observed, one type of van der Waals force of attraction, and that type of van der Waals force of attraction is, there are different types of van der Waals force of attraction, and one type of van der Waals force of attraction that has been observed in non-polar molecular solids is London force. Whereas in the polar, the best example for the polar is, I can take it as HCl, where there is a polarity between hydrogen as well as in the chlorine. There is a vast electronegativity difference. Chlorine has a high electronegativity, whereas hydrogen has low electronegativity. There exists an polarity between hydrogen as well as chlorine. And there is also, we can observe a type of one type of van der Waals force of attraction, and that van der Waals force of attraction which can be observed in the polar molecular solids is dipole intermolecular force of attraction. Coming to the last one is hydrogen bonded molecular solids. The name itself indicates it contains hydrogen bond or hydrogen bonding. The best example for this is water in the form of ice, H2O, which is in the form of ice. And the constituent particles in all these three constituent particles are molecules. If you observe, I2 is a molecule, HCl, H2O. Constituent particles are molecules. Coming to the last solids are metallic solids. Coming to the last concept is metallic solids. Metallic solids, the name itself indicates metals. Generally, metals are good conductors of heat and electricity. They are malleable and ductile in nature. They are malleable and ductile in nature. They are good conductors of heat and electricity. And the best example of metallic solids is any type of metal. Example, any type of metal like sodium, magnesium, etc. And type of force of attraction existed is electrostatic force of attraction is observed. Electrostatic force of attraction is observed. Basically, they are good conductors of heat and electricity, meaning, example, if you take a sodium, sodium will readily loses one electron and turns into Na plus and one electron. And this is called free electron. And these free electrons will conduct electricity as well as heat. And this is regarding the concept of classification of solids. Generally, once again, we will just have a quick review on what we have discussed today on solid state. Solid state, we have generally discussed the definition of solid state and the general characteristic features of solids and the classification of solids. Only three parts we have discussed today. One is definition, general characteristic features, as well as classification of solids. Classification of solids is of two types. One is based on the order of arrangement of constituent particles. Another one is based on the type of intermolecular force of attraction between them. And we have gone through order of arrangement of constituent particles is classified into two types. One is crystalline and amorphous. Another one is on the basis of intermolecular force of attraction. And there are four types. One is ionic solids, covalent solids, molecular solids, and metallic solids. This is regarding the general introduction of a solid state. Just to have an quick screenshots of all the today's concept.